when we're talking about, like we just have been, about very large language models and huge costs on GPUs, that isn't necessarily where everything is going. I mean, so we do have this trend towards gigantic models like we saw with GPT-4, with Claude from Anthropic. These models are getting bigger and bigger. But simultaneously, there is also a trend towards small language models, SLMs. And during a recent ODSC podcast, we were talking about ODSC earlier, so I
Yeah.
assume I didn't actually listen to this episode, but I'm guessing it was hosted by Seamus McGovern, as usual.
Yep.
Um, and so during that recent ODSC podcast on small language models, you discussed deploying SLMs into production. So could you fill us in a bit more on SLMs and what it's like working with them relative to larger models, why somebody might want to use an SLM instead of an LLM?
Yeah. So let's say that ever since there's this push to make models larger because capabilities have evolved with scale. So we learn from OpenAI and then everybody else following that trend, um, that as you scale up a certain architecture, be it transformers or other architectures like that have shown similar gains in performance as they scale up. It's kind of a universal property of something doing certain kinds of computation. It doesn't need to be a transformer. But what we know right now is that if you scale things up, your the capabilities will also increase for a certain set of data, for a certain task that you want your model to solve. In this case, next token prediction, right? You give it a huge corpus and then say, okay, if I give you a chunk of tokens, like fragments of words, what the next one? Or assign a probability in your gigantic vocabulary, your 30K possible tokens. Can you assign a probability to each one of them getting next, being next? And then going through this process, the model generates some sort of internal representation of higher order concepts, I would say, that can be that you can have an experience with as a human interacting with the thing. And then the other property that we saw, and then I'll come to your question specifically, is in context learning. So prior to a certain point in time, to solve every task, you had to train a model on that task. So you had to have a lot of data annotated for that task. And then it's still true for many disciplines. I've done a lot of work with AI in manufacturing context, and that's very true there. But in language specifically, and then vision as well, in some cases, you can train models that are kind of more generalistic, and you can direct them to a subtask or a task that is kind of somehow related to the original task. By either fine tuning them, so using gradient descent to change their parameters or a subset of those, or a layer on top of the parameters you have, um, to adapt the behavior of the model. And that kind of biases generation in a certain direction. It doesn't really add a lot of knowledge into the thing, but it's probably amplifying things that the model has in it. But also you can do in context learning, which means you can explain through the task that you want out of the language model by just writing it in the context, and then even providing examples, and those help the model again bias their output in a certain direction as well. And what has become quite clear once ChatGPT was released and then Llama came and so on, was that there was a process of miniaturization where practitioners starting to look for smaller models that maybe had fewer facts but could still retain those properties of in-context learning and being general and adaptable to different tasks. And what is usually happening is that small models are better at specific tasks than general tasks and are worse at in context learning. Um, Although this is like incrementally month after month, and months are very long time scales these days, uh, are getting a lot better. Like I remember the first time I used Llama 3 8 billion, um, I said, well, this is giving me a few vibes of the initial ChatGPT, right? And it was running on my Mac locally, right? Uh, and then you start seeing 1 or 2 billion models obtained through distillation of larger models that are starting to get that kind of like, but they don't need to be perfect. They need to be good enough, and then hallucinate not so much. I've seen other models in the past that were small, like Phi. The original Phi hallucinated a lot, although it had good metrics, but the hallucinations were a bit too many. I think Llama 3 8 billion was one of the models that didn't hallucinate so much, at least on my private test cases that
Yeah.
I have.
But that's the 8 billion. That to me, that's starting to be like, that's like a small LLM. I don't know if I would say like, it's funny. It's kind of, it's right on the cusp.
It's on the
So
cusp. Yeah.
when you're saying 1 billion, 2 billion, for me, that's a small language model for sure.
Yeah.
It's interesting when it's like 8, it's like, yeah, it's right on the threshold of, it's a smaller large language model, but it's still, it's not super portable
Yeah.
on modern phones, that kind of thing.
Yeah. But I mean, this will evolve, and probably 1 billion, 2 billion will become, yeah, as we learn how to distill things. Like we did some investigation with an intern this summer, and we saw, and we'll probably publish it at some point, that actually he already published a part of the findings, and and many other papers are looking at the same thing. Like even 8 billion models or 2 billion models are undertrained. There's a set of parameters that is doing nothing, and so like think about this. Like we landed on something because we wanted to scale it up, and we saw that just by scaling up, they gained a lot of we gained a lot of features, but we're still at the very very early stages of being able to say, okay, are we actually using this and all the parameters in a way that makes sense, or we're just shooting, and it's like
Totally.
the latter is true, and we're seeing that um, distillation is doing something that kind of compresses and makes things more efficient, but again, it goes together with interpretability a little bit, but it they're uh, squeezing every inch of performance or every inch of capability is, we're very far from there. And also facts are also polluting and occupying a lot, and so reasoning and knowing everything are two uh, different things, right? And so even the way, like, uh, having to train on trillion sized data tokens data sets, and having to memorize all these facts are all things that are pointing in the direction that in a couple of years, in 1 or 2 years, we'll get the same, like, good enough for interaction kind of vibe from models that are like, yeah, no more than 1 2 billion for sure. It's a tendency, like when we had like the boom, like the radios, and then we had Walkmans. Like it's kind of inevitable. I don't think we're hitting any fundamental property. Yes, there are scaling laws, but scaling laws are a result of conditions, um,
Right.
like of there's a certain set point at which they're being formulated,
Exactly.
and then it's universal if you put yourself under those constraints, but it's not universal in the
Exactly,
absolute.
exactly. It's it. So the idea of something like the chinchilla scaling laws, that makes sense under the context of a specific budget, for example,
Yep.
or a specific amount of data. And so when in those kinds of scenarios with those constraints, you're like, okay, if we scale up the number of parameters, it will have this effect. But of course, that doesn't take into account how can we be more clever about distillation or pruning to allow us to make the most of all of the parameters in a 1 or 2 billion parameter model. It
Yeah,
is
yeah.
interesting to hear, though unsurprising to me to hear, that you had an intern that was able to discover that even on a 2 billion parameter model, there's lots of parameters that are being unused across all tasks. So there's still,
Yeah.
more juice to be squeezed from that lemon.
Yeah, for
And
sure.
it's kind of obvious to me that, you hear these kinds of you hear in the press, in the popular press, oh, right now, training a state of the art LLM costs in the area of $100 million. The next generation will be $1 billion. The next generation will be $10 billion. And I don't think that's true because of exactly the conversation that we're having here, where yes, that instrument, that hammer of just scaling up model parameters got us from GPT-2 to 3 to 4. But once you're at OpenAI and you're looking at, wow, this is going to cost $1 billion or $10 billion to train the next generation of models, and then deployment is you still have this. Then you're going to have 10x, 100x costs and deployment as well. It's not possible. It doesn't make economic sense when there is so much juice to be squeezed from the lemon in other ways. Distillation, pruning, as we already talked about with small language models, and also now with paradigms like we see with O1 from OpenAI,
Yeah.
you can be scaling inference time compute as opposed to training time compute.
Absolutely. Yeah, that's the other thing I wanted to mention too. Like right now, we use LLMs like zero shot, even within context learning. But it's again, we're scratching the surface. It's so early. If you read around, it looks like everything. Oh, it's all set. Like but we're like, it's not even the beginning. So approaches like I was reading about entropics in these days. This method to kind of dezoom whether the model is confused at a certain point of the generation, so that you can give it more time to sample differently. And sampling is just one of the ways you can do things. And think about like the effect that LoRa has on weights. It's a surprisingly small amount of information that you're adding, right? But you can pretty dramatically change the behavior of a model even with those small amount of numbers. That means that a model has in itself the ability to produce a very diverse set of outputs, and we just need to bias it to produce those. And going through gradient type of methods and optimizations is one way, but I think it's a way that it's a bit indirect. Like I think the real opportunities will come when you have a knob that you can turn real time to kind of tune exactly what you want out of a model, or give the model the ability to real time kind of bias itself towards behaviors without necessarily going back and do the whole Adam optimizer blah blah blah, right? With examples and so on. That will stay there for sure to create the basic models and also to align them and so on. But I think we're getting into inference time compute period of time where the knobs will be a lot more visible. And even from a business perspective and compound AI systems perspective, that's where we will be able to squeeze a lot more value out of the systems. And we'll learn that small model know a lot more than we think.